Well, hi everybody. I'm Mike Pickering. I am from Spectralogic, and I'll put our faces up on the screen in just a moment here. And I am with the I'm with Spectralogic's federal sales team. I support customers across the federal civilian space, as well as Department of Defense and the IC as well. And so I've got quite a bit of experience here, specifically around object storage and that sort of thing for the last 15 or so years. Certainly doing handling government solution building for the last 20. And prior to that, I was a government contractor for many years. Matt?
Sure. I think you discount yourself on your knowledge of object storage. From a sales perspective, there's few people that I've ever met that know more about object storage than you do. So you have the history and the forward-looking side of that. I'm Matt Starr, field CTO for Spectralogic. I've been with Spectra for this is my 35th year. I cover our U.S. federal business, our Asia Pacific business, and then our HPC business worldwide. So I overlay on HPC worldwide. So next week, I'll be going to international supercomputing in Germany. It's always been a fun place to work.
Well, I can imagine. I certainly wish I could say I've been here for 30 years. I've only been here for about 4 years. But I appreciate your kind words regarding the underlying technology I've been so close to, which is object storage. It's certainly central to a bit of the conversation I think we're going to have today, but it also talks widely about, how government agencies are really trying to, do more with less. Lots of things are always changing, but I'm going to boil down one variable, and I don't think it can't be ignored right now, which is a significant change is the new administration, right? 2025. We now have agencies who are suddenly looking for quick wins on some cost savings. And one that just keeps drawing a lot of attention, like a lot of attention, is cloud cost. Much more so than just even a year or two ago or things like that. And we at Spectre, we've been talking about this concern for many years. It doesn't necessarily mean it's on everybody's radar. In 2025, it certainly is. Cloud archival, in particular, it's given everyone a pain in the wallet, a pain in the budget in the public sector, and they're now speaking up about it. This year, there's a lot more of that thing we talked about at the kickoff of this call, which is doing more with less, and some tough choices need to get made.
So where's the fit for Spectra in that ecosystem when it's cache and a lot of content?
From our perspective, we've got our on-premises alternative to cloud storage, right? It has increasing appeal each year. So we got so many applications and workflows that now use those open cloud APIs, such as the Amazon S3, compatible API, and then the extension to that, which is the Amazon Glacier compatible API. Spectra's enabling missions to write and draw from these deepest archives, right? So you're tiering mission data from like solid state disk storage, like I mentioned some of the other partners you'd see typically at these conferences that we work with, down to tape storage. And it doesn't get more secure than that. That's as secure as you're going to get. But the thing is, even with the archives growing into like exabytes, the cost is lower than the lowest cost you're ever going to get in the commercial cloud, like the
Yeah.
commercial offerings, let alone the somewhat costlier, we'll call them government dedicated gov clouds that are out there.
Yeah. There's certainly a price uplift for those. So
Yeah.
what is Spectra's deep archival system based on?
Well, I know so you're lobbing me a softball. But we're always assuming that everybody on the call is not always aware of what we do. And what we've been doing out of Boulder, Colorado, certainly you've been doing it there for decades. The underpinnings of Deep Archive is what you'll find that's actually now in every hyperscaler, every cloud, and that is it's tape. Sometimes we get more than a few folks who put a look of surprise on their face that the most modern on-premises supercomputing workflows and cloud workflows out there, they rely on tape. But it's a medium that continues to modernize. In fact, like yesterday, literally yesterday, and today we've got announcements, press releases hitting that announce the arrival of the LTO, which is a format for tape, Generation 10, literally just dropped, brand new, it's going to be released in just 2 weeks.
Yeah,
Uh,
great.
yeah, I mean, you saw how that was coming along, and now
Yeah.
we can speak openly about it, right? Which is, we're talking, Matt, we're talking 30 terabytes a tape cartridge, and compression support. What's that going to get us up to?
2.5 to 1. And more importantly, I think, is no power. And that's, the interesting part here is when you look at these new workloads, power is starting to become a factor for data center guys.
Totally, totally.
Yeah.
And so if we could achieve pushing up towards 70, 75 terabytes per tape, and getting into that exabyte scale neighborhood. This is something that's super secure. You're getting the air gapping for all the security compliance, that we all worry about. But these security rules sometimes are also retention rules, right? So they got a lot of long tail, data retention regulations and tape wins there. I mean, no one's no one's going to park any of this data on solid state or even spinning disk with those kinds of requirements, but they've been parking it on tape for decades. And when you're thinking about 20 years of data storage, uh, it's tape.
Yeah.
So kind of exciting, kind of neat to see that that appeal now growing into the geospatial space.
Yeah, it's interesting. I did a presentation at the Rocky Mountain Supercomputing Show last week. And at the end of the show, the guy was asking a question, and I'm going to pitch the question to you. How do I use it? How do I make it easy? Right? Because they've always heard tape is hard. So how do I make it easy? And that was
Oh,
the question the guy asked me.
I know. I bet you. I mean, we hear this question, and you can always complicate it if you like, but it doesn't have to be anymore. And so people have maybe thought that they had to just do a lot of things with their hands and all those sorts of things. It's actually easy. I'll call it on Matt. I'll call it on two levels, and because it's easier on the user now and it's easy on the data center. You mentioned earlier that low power draw and dense footprints that we can do. So it can fit into data centers that are getting stressed by, AI that's, pushing power grids and what people have leased in terms of electrical power, pushing the edges. Now we're able to do just a cloud archive in a box. I mean, that should be on the front of every one of these things. It's a cloud archive in a box because
Behind your firewall, right?
right, exactly, behind your firewall, because you can tie in this low cost, low energy archival at any scale. You can start small, really small, 6 rack unit, or you could start really quite large, like some of our largest customers. But again, this whole thing of using something that's just easy, you can use it as just a set appliance, set it and forget it. Kind of exciting.
Yeah. It's interesting. You brought up a little bit more about power. Most people don't understand that when you get to scale um, of tape versus disk, it's 1,000 to 1. In other words, a disk subsystem with its cooling and a PUE of 2, that disk subsystem is going to pull 2x or 1,000x the power of that tape system. So when you're looking to claw back more power for your AI workload, that's one of the places you can look is how do you get this cold data even colder and zero power. So when we think about this and the archives are growing for on-prem, where does it leave the cloud guys?
Well, that's a good question. And again, you mentioned some technical jargon there. I'm not sure everybody follows you. But then again, guys, I want to be very clear. Matt Starr hasn't just been with SpectraLogic for 30 years. He's literally got patents hanging on the wall. As a matter of fact, I think I still have that slide up. So that, yeah, there it is. So he knows a lot of things about the underpinnings of this, but those underpinnings make real dollars and cents facts for us every day. And so that's exactly where we're living, which is can you survive in a disk and NVMe or solid state flash world alone? And the answer is at this scale, it's not going to work out that well. But you ask the question like, where is this leaving, cloud usage? Like, what are we going to do? Well, the thing is, we mentioned earlier, and we can't stress this enough. Yeah, dense archival tech that also uses the latest modern APIs. And I can't stress enough when you're using the latest APIs, that means each agency, right? They're able to embrace cloud where it makes sense. And what does a cloud really do well? Is it a great dumpster? No, it's a costly dumpster. But one thing it does do really well is when you want to pay by the API call for AI and other compute cluster behaviors, stuff you'd rather rent than host. So I think everyone here is touching, federal agency data center planning and thinking about what you should have local and what you shouldn't have local. And so the multi-cloud trend is also continuing at the same time. And if any of you have been keeping up with the multi-cloud conversation, knowing that certain clouds specialize on certain tasks for the overall mission. Some are good at some things, some are good at other things. And it's always changing, by the way. So if you're a savvy app and cloud architect and you're on this call and you're thinking, okay, what am I going to do here? Well, I could actually leverage S3 API compatible, and friendly deep archive. And maybe I could have that on-prem, but I could actually have it connecting to more than one cloud. Years ago, I worked for pretty smart CEO, and he said cloud is the new network. And again, I can't stress enough, he didn't say cloud is the new dumpster. It's not a data dumpster. It's not effective that way, but it makes one heck of a way to connect your mission partners and other folks you're drawing resources from. That's where cloud shines. So continue leveraging cloud for what it does do well. If you're here for any particular complex workflow across government, you got to stay connected to those mission partners and draw from the best functional assets out there. I get, they often say the network matters. Well, yeah, that's cloud. That's smart cloud in a nutshell.
Yeah. So since you've brought it up, so let's dig in here. With the talk about the API, we're clearly talking about object storage and not file storage. What's going on with that? I mean, is it new stuff in object storage?
Yeah, probably one of the key reasons I came to SpectraLogic. Talk about new stuff in object storage. It's just been a long time coming. My own experience in the last 15 years as an object storage champion, right, is seeing various workflows adopt object at different paces. Because, for example, the high performance computing crowd, the folks at the various national labs and folks like that, they were actually late to the party because it kind of made sense why they were late to the party. They were often using, your POSIX style, folder file system, data movers, and Matt, you and I work with these things all, to this day, work with them all the time. Because they're moving data locally, right? There's oftentimes not a huge amount of data collaboration. It's worth noting that many of these labs were, funded individually, and a lot of times these labs had very individual local activities. That has changed a bit, but the GeoInt crowd, on the other hand, they were much earlier adopters of cloud for mission collaboration, and in part because they were drawing from some really high performance, commercial satellite operations. Private industry really stepped up. And while yes, the government, makes some really crazy high-end satellite technologies for their own missions, they draw so much more as a percentage of their overall mission capability from commercial birds than in the past. As a consequence, it really encouraged them to be deeper into cloud APIs for quite some time. These folder file systems work great in a single data center. They fall down when you're trying to pass across networks and go across distance and handle latency friendly. And there's all sorts of vagaries there about where file systems fade and object storage stepped in. I think that's really what happened. But again, now we've hit that early adoption, that heavy adoption, as cloud is sort of colliding with 2025 and what we were talking about earlier in terms of the need to reel in some of those costs. So again, maintaining that object adoption, yeah, definitely got to do that because it really helps the mission and keeps everything flexible. But I would say that if for some quick wins, lowering the archive cost, and that's why these customers, call on Spectra.
Yeah, so let's jump back. Let's expand a little bit and jump back. So do they allow a mixed workflow, mixed technology in there?
Oh yeah. I mean, so lots of conversations with our peers in there in terms of I think of data protection and data movement as well as primary storage capabilities, right? Tied in with deep archival. I keep using my hands showing these tiers of sort of
Perfect.
a wedding cake. It's a layer cake. It's even a
That's
wedding.
right.
And so for example, with some of our friends that were there, think of like in traditional enterprise IT, where there is a bit of that in the GeoInt space. Think Cohesity and Commvault and things like that. But also, a lot of the lively conversations we had were with our friends over at like Hitachi and NetApp, where there's performant tiers, those solid state performant flash tiers, and then active archive object tiers, and then tying in our deep archive. But again, and I sound like a broken record, the modern API support there shines because all these players I just talked about, they're supporting these latest APIs. They know how to play nicely with us, and we know how to play nicely with them. Because what drove that? Overall, what drove that was cloud adoption. We all agreed, back in my earliest days of object storage, we had several REST APIs that weren't all using the same one that was popularized by the Amazon S3 API, which ended up, we'll call it the winner of the compatible APIs out there. So all of these things have really become much more uniform. All of these products play nicely together, and it allows customers to age off mission data after initial likelihood of mission need and move it down to these tiers. And so with all that going on, this caught the eye. Oh, and by the way, to save money, right, with budget to spare, this caught the eye of more than a few of our defense integrators. Because I mean, they're right there in the midst of it. They're on current contracts and they are under pressure to do more with less. And oh, by the way, the government asked them in the next breath, hey, expand the capabilities.
Yeah, make it bigger and cheaper. So did they come to you with specific requests, or were they just looking for ideas? What level was that?
Oh, yeah, definitely they came with, I'll call them both kind of almost requests that were practically warnings, like, hey, I'm going to need this. So this guy was talking about 10 petabytes a day of ingest. And
Wow.
I mean, yeah, I mean, for those of us who are familiar with that, like, with today's commercial satellites, supporting crazy performant optics, jaw-dropping resolution capabilities, right? You think about all the things that have gone into your iPhone. Well, a lot of those things 100 times over have gone into satellites circling the Earth, and that's why we get such amazing pictures we could have dreamed of 10, 20, 30 years ago. Well, anyway, he's looking at these technologies, and they are these staggering numbers. This is increasingly typical. So when he walks up to us and says 10 petabytes a day of ingest, I'd love to say I'm shocked, but I can't say I'm shocked. That's becoming the new
Yeah.
norm. So you think about people who are addressing the ability to get the downlink from that. And so, people who are scrambling to build the networking to pull that off. That networking and that backhaul, if you know your networking space, that's their problem. But I'm closer to our part of the workflow. We're concerning ourselves getting performant primary storage in there with the usually flash-based solutions, highly parallelized I/O, hence what we were talking about earlier, Matt, all those data mover friends of ours who move data so very quickly. And then you're getting that geospatial ingest and initial analysis challenge solved, right? So the operators are happy. We need them happy. However, it can't all live there. It's got to move down quickly out of those tiers because having the operators happy is great, but if you can't afford the system, government's not going to operate it. And so we move these data with the data down, and tiering GeoInt life cycles have to throw this stuff down, not out. And if you throw it down to this deep archive tier that supports these APIs, it's just a pleasure. And that's where these industry conversations, invariably head Spectra's direction. Because we've been, offloading data from supercomputing clusters for
Yeah.
decades. And now we're just doing it with the latest cloud APIs.
Yeah, it's media and entertainment for us. It's things like supercomputing. It was interesting. You mentioned something about that 10 petabyte system. It's because the resolution, what we see on Google Earth or Google Maps or any of these geospatial publicly available sites is a much lower resolution. That's what's actually coming off the bird, right? It could be 10x lower or something, but their data is a massive data set, and then they transcode it down to something that is palatable for public consumption. So yeah, kind of interesting.
I should, point out the next thing we're going to talk about a little bit is what we do at Spectra in terms of our portfolio. We couldn't drag all these things out there. We kept a small footprint and that sort of thing, and we stayed nimble to have a lot of conversations with our industry partners. We had a little bit of headwinds on this. We had some customers, for example, weren't so freely able to travel, so some connected virtually and things like that that hem you in a little bit on uncertainties on budgets and strategies. Again, we keep saying We're in 2025. It's a different situation. But in that environment, Matt, I think we actually, a lot of the technology companies, a lot of private industry made a point to interface a bit more aggressively, and to update some of these workflows as we'll call it as a service to our end customers, to devise some cost savings wins and put together some new flows, which invariably, by the way, on the floor, it's not just a marketing gimmick. Plenty of these things now have AI traits to them, which is speeding up the process for the analysts, for the operators. And I think, the next few years will be a turning point, and we're looking forward to helping.
Yeah, it's interesting. You have the as we call it, the family photo up there, and that you mentioned earlier about LTO 10 coming out. So that makes that one library, the second one from the left there, that makes that a 50 petabyte box, right? With no compression, that's 50 petabytes. And the one to the farthest to the right is over an exabyte. So your 10 petabyte guy, he's compared to our Tfinity there, he's kind of a small fry, right? I mean, he's putting in 10 petabytes a day. That's nothing for that size box.
Right.
It's a spec.
Well, and the neat part is I always hesitate when I put this the family photo slide up, because you can think to yourself, oh my goodness, I don't possibly have that much data. And when could this be economical? But the funny thing is, and we won't bore you with all the slides and things like that, but on the left side, that Spectra stack can actually start small, just 1/7 of its size that you see listed there on a 42U sized rack. And the neat part is a customer can grow into it and achieve startlingly low cost. I'll call it their blended cost per petabyte, because yeah, I mean now you can put in 42U in that height. You can be servicing a nearly 17 petabytes, uncompressed. That's the native capability for those the tape cartridges we're talking about in those slots, pulled up by a robot, and then expand when needed. But the neat part is you couple that with one of our gateways. In fact, I'll show that to you on the next slide. You partner that with one of our gateways, and suddenly you're speaking the S3 compatible API, the Glacier compatible API, to very dense archival. And before you know it, you've back-ended a data protection software or a primary storage tier.
Well, yeah, and I think that's the beauty of object storage, right? You're not supposed to really know what and how it's stored. The goal of object storage is, the equivalent of valet parking. You pull up your car, you get a ticket, and when you want your car back, you give them the ticket. And object storage, going off to tape or off to disk, you set the policy and it goes to the right endpoint. So it's a very fitting place for object storage to be, because you're not supposed to know. Your administrator knows, but you're not supposed to know the ins and outs of object storage. You just have a put get interface.
I'm glad you pointed that out, because when I started talking to this about to people 15 years ago, we said, "Oh, well, what's the thing you're talking about? Is it SAN storage? No. Is it NAS storage? No." And it's economical. And at the time, it was disk only storage. And then we would explain exactly that concept of saying the application knows where things are. You, as a person, you're not having to click around and find those things. It's stored in these buckets, and these buckets are driven by the applications that understand them. They said, okay, fine. They understood that. But now we're taking that same object motif down all the way to the extreme affordability of tape. And so one of the things that concerned people about tape is I'd have to know too much about where things
Yeah.
are down in the tape tier. And we're able to say, no, whether you go with this littlest of the tape library portfolio, or the really big one there on the right side, which tends to be for large national lab customers and large media and entertainment customers, the same rules apply, which is your application just simply knows they're drawing from this bucket, those puts and those gets you were talking about, whether they're grabbing something from our NVMe tier, our disk tier, or more likely, our tape tier. And it's neat to get people to go, oh, aha, I don't have to twiddle that bit and twiddle that bit and get close to those things. I can let an application abstract that for me. So
Yeah.
yeah, folks, I just want to make sure you've seen the items on the screen there. They certainly speak to that. Let's take a look actually for a moment here with this one called the Spectra Cube, because I'm going to show you a slightly different flavor of it with that that S3 compatible API gateway actually mounted atop. We talked earlier about the idea, what do we call it? A cloud in a box, behind the firewall. And you can have that experience with a pretty reasonable footprint. Just so you know here, this is we'll call this, 3 foot wide, 3 foot deep, 6 foot tall. And when you think in those terms about, oh, this fits in my data center, this is not something that I can't do. This is something that connects up very simply. It's going to connect simply from your IP networking within your environment, and lo and behold, you've got object storage in your environment. You
Yeah,
could,
so you're taking a 10 gig E, plugging it in,
right.
and serving up puts and gets.
And if you've got a distributed environment in your agency, this is an object here that can be targeted from a variety of sites because, of course, when you honor S3 compatible API traffic, Glacier
Sure.
compatible API traffic, distance doesn't really matter that much
How
anymore.
the web, it's how the web works, right?
Yeah.
So the other thing, when you think about file systems versus object storage, you think about file systems. When I lay down a new file system, I buy the newest, fastest, company X's uh, array, and I put it down. I put a file system down on it. I have to copy all that data over, right? In the case of object storage, the tenet has always been you don't know what's behind it. So what happens on a migration when new technology comes out? What happens? The next generation LTO drive.
Well, I mean, the cool part is from our perspective, I like the way we abstract the customer even from that problem because we can actually mix and have more than one,
Mhm.
LTO tier within the body of the tape library, and we also make it very self-serviceable, which is kind of a neat departure and not all that common in the industry, so that you can have a couple of generations running concurrently, and that's really why, it's kind of a thing with Spectra. We've got customers who will run these environments for not years, but decades. And they
Yeah.
will be able to grow generation to generation, while it just simply appears to be just this part of the workflow that's just always doing its job and saving money at again, I mentioned earlier, the equivalent of the lowest cost pricing you ever see in deep archive for cloud. You're able to do this on premises for that same equivalent when you look at it over 3 years or 5 years. Just a neat thing to add to your environment that's been modernized. In fact, true story. This particular model was a recent model that arrived because one of the growing verticals we have in this space is to service hyperscalers and clouds. And so this one was grown out of this cube was grown out of the R&D to develop something that was very friendly to hyperscalers and clouds because they wanted to see something simple, appliance, don't want to touch it. However, when we enabled it for enterprise IT, for federal agencies and media and entertainment customers and various other folks, um, we made sure that it still had some of the self-service and some of the abilities to do certain things they might want to do. Some organizations still do want to be able to eject tape cartridges in these. In our case, we make them very simple because they reside in these 10 packs called Terapacks, and just be able to eject those and be able to move them out for the simplest disaster recovery strategy. So we maintained that capability, which is a bit unique in this space for hyperscaler designed tape library tech. So just putting it out there, making sure everyone out there sees that. We've designed with a couple of our models of that gateway that's sitting atop there. We call that gateway, by the way, Black Pearl. Don't worry about all the brand names of the products. Just call your Spectra friends when something like this makes sense. But and certainly call Carosoft. But we've actually done different models there because now with our latest model, we're doing an all NVMe design. We're
Right.
seeing maybe the industry, maybe we're seeing a bit less disk-based solutions and a lot more solid state, but then tape is growing. So it's kind of meeting in the middle. We're finding a lot of NVMe straight to tape library as well because you get to put in just a smidgen, that's a technical term, just a smidgen of the NVMe before you're able to write to the density of tape, and the cost per petabyte is staggeringly low. So,
Yeah,
um,
it's interesting that tape library there holds, if it's holding 16 or 30 half-byte drives, depending on which generations you're at, those tape drives are doing gigabytes per second when you start to aggregate all those tape drives together, right? So when you think about the need for speed in there, you need to be landing on flash so that you can move it out to the archive. But that archive is going many gigabytes per second in or out. So flash is one of the storage technologies we have to use just to make the rest of the system fast.
Yeah, feed the beast with
Yeah.
NVMe on the front end, and that should have a few of you who might be watching this saying, "Wait a minute, tape? I didn't think we'd be having that kind of conversation of this is a speedy affair. What we're talking about." Tape, in some ways, in the aggregate, can be actually quite speedy and quite enabling for your mission. And by the way, when you're getting data back in that kind of speed, it's so much faster than the cloud-based tape
Oh
library
yeah.
you've seen out there, where you'll see their SLAs advertised on those websites, where they'll say, "Oh, you'll get the first data back in 4 hours to 2 days." I don't know how that's been appealing to folks, but there it is. It's out there. With us, you're getting data back
Very
just
good.
about momentarily. So
Yeah.
it's really pretty exciting that it gives people a wake-up call to say, oh wow, if I partner up solid state where it makes sense, disk where it makes sense, and tape, I've got a heck of a workflow that my geospatial analysts and operators won't complain about. But I can also reach back and mine that data for AI and ML and start do those LLM studies and all those other things. Draw that data back when I need it and not lose it. Because we're seeing everything from cybersecurity data to obviously large amounts of imagery, sensor, you name it. This is the sort of stuff you got to put down on this. If you're doing modeling and simulations, things like that, if you own a super collider, you obviously are probably already a customer of ours, but there's so many other missions that are out there where you should really be looking into this kind of technology. And our friends here at Carosoft will certainly point you our way. Um, the other things we should certainly not forget about is, you can do immutability in terms of very
Mhm.
strict handling of the data for compliance, even while it's still in the initial steps before even writing down to the tape tier. Obviously, this is a huge capability that avoids ransomware attacks by private entities, but also nation state attacks. And everybody has to concern themselves with that across private industry as well as the public sector. So again, you don't have to go exabyte immediately. This can actually be economical if you're just even starting in this space. I'd say in the high terabytes, low petabytes, this could be uh, pretty compelling. So
Yeah, I would say that, if your data is growing uh, at the same rate as the storage roadmaps are growing, you're probably a candidate for this. Just like, we talked lightly about it earlier on, which is media and entertainment. So, if you look at all the content that's ever been created in the world, let's just for today, let's take the United States, all the different channels that are playing. I'm going to say that 90% of that, 95% of that has a copy of it on tape. As a matter of fact, most of the studios in the world tend to put the original content, they treat it like film on tape. And then they may bring it up, edit, and do cuts, but they're never messing with that original content after they've ingested it back into the studio. You look at oil and gas for seismic information, all of that data is on tape. If you look at our Department of Energy friends, every Department of Energy site in the United States has tape as their archive, and they're using a lot of it. Some of them could be exabyte scale. So it's one of these where most people don't know how to solve this problem. And then when they hear about tape, they're like, oh, this is why other people can do this. They can do this because they're using tape. The cloud can store exabytes of data cost effectively because they're using tape.
yep, the secret's out.
Yeah.
And now people just say, give me a cloud in a box. It's got to be easy,
Yep.
turnkey. And that's exactly what we're talking about here today. Uh, Matt, do you think we've covered it in
I,
terms of
I
passing
do. I
it
think
back
we've gotten
to
most of it
Mariana?
out. So yeah, I think we've covered everything we need to. Mike,